Hello students. Hello. Welcome to the lecture. So today we are going to see a topic. It is a design thinking based topic in the course Finite Element Methods and Analysis. So let us proceed to the problem. So for today's lecture I have prepared a problem, right? So before into the problem, I would like to know about the different things about the conduction, convection and radiation, because this conduction, convection and radiation is directly linked with this problem, right? So here I will just tell you the problem. So I would like to hear about what is the conduction, convection and radiation from your end, right? So this is a problem. So you can listen here. So you are seeing here three rectangular partitions, right? So these are nothing but that it is a wall, right? So here if you see there are three walls, right? So here it is having a thermal conductivity K1, and wall number 2 is having thermal conductivity K2, and wall number 3 is having thermal conductivity K3, right? So this is the inner side of the wall. This is the middle surface of the wall, and this one is the outer surface of the wall. If you see all these surfaces, you can see here this outer surface is exposed to the atmospheric temperature. So here the conduction takes place, right? And if you see the inner side, the temperature of the wall is somewhat different, and the middle end, the temperature of the wall is somewhat different. So before into this problem, so can you say about the difference between the conduction, convection and radiation?
So basically speaking, conduction is a type of heat transfer, sir. Basically, it's a type of heat transfer in which the direct contact between the source of heat and the object that is getting heated gets direct contact to it. So considering real life in applications or real life examples, we can take our simple example of boiling water in our kitchen, which is take the example of boiling water. The vessel is in direct contact with the flame from the stove. So this is a simple example for the conduction of heat transfer. Yeah.
Yes. So can we give him applause? Yes, he's exactly right. Right. So conduction is one of the concept of. Please take your seat. Right. So conduction is one of the heat transfer concept. Here, the contact between the heating element and the source, heating source and the object is direct contact. So if you explain with an example, the perfect example for a conduction is heating or boiling the water. So the vessel is directly in contact with the flame of the gas stove, right? So the flames produce heat energy. That heat energy is transferred from the vessel to the water, so it boils well. So this is a perfect example for the heat conduction. So the heat here is conducted.
So while coming back to convection, convection is also a mode of heat transfer where the heat is just transferred from one object to another. But the difference between the conduction and convection is that in convection, the warm air always flows to the less denser air. I mean, like wherever the higher denser air will be moving to the region where there is less dense of air. We can just notice this in the real life example of rainwater cycle, like the water, I mean the sea waters are getting, the temperature of sea water is raised up by the sun, and they become less dense and they travel upwards and form clouds and give back as rain. So the sea water, which is denser, is getting heated and it's converted into less denser air that moves upward and form clouds and brings us rain. So that's an example for convection. Yeah.
Yes, very good. So if you see, the next concept is about the convection. Here there is no direct contact, it is an indirect contact. Here it is air. Here the working medium is air. Example is air. So he told one example, that is the sea water, because of the environmental condition, what happens? It becomes hot, right? It becomes hot, right? Once the water becomes hot, what will happen? It will get evaporated. Once it reaches its maximum boiling point, what happens? The water is converted into gaseous form and it is the molecules are transferred through the air to the clouds. Once the clouds are getting condensed, they are also condensed, right? Heat is condensed. What will happen?
The rain is formed.
Yes, rain is formed, and the particular place the rain will fall. So this is what another example of the convection, right? So what is radiation then?
So in radiation, this is a concept of heat transfer, but in direct contact, it is an indirect contact which is an electromagnetic concept where the example is solar water heat system and heaters which use an infrared rays for the heat transfer, which doesn't travel through air or any surface. It directly contact with the people or any other object in the environment. So this is the concept of radiation.
Yes, good. So if you see radiation, I will tell you one example, right? So if there is some heating is taking place, right? If some unwanted particles or waste particles are fired, what happens? You will feel the heat through the air. That is nothing but the radiation, right? So it is because the heat in the particular place travels through the air. So you will feel in your skin that there is a temperature. That is nothing but the example, radiation. So this is how in FEM. So today you have learned the concept of conduction, convection, radiation with different examples through a design thinking approach, right? So this is what we implement in the finite element methods and analysis, right? So this is the application problem. So in this problem you are asked to calculate what is the heat at the different nodal points. You can see here T1, T2, T3, T4 are the nodal points. At that particular point, what is the temperature? So the conductivity of the material is represented by K1, K2, K3. The environment temperature is given, right? So this wall is subjected to a heat. So at different nodal points, what is the temperature of the wall? So that is what you have to find. So this is how the concepts are applied. So accordingly you have to input the conduction, convection, radiation. There are several formulas. That formulas you have to incorporate in the problem, and then you have to find the result, right? So I hope this gives you a better insight to solve the problem practically with application oriented, as like today's class, to a design thinking approach. So let us meet in the next class. Thank you.